Well, hello, good morning, everyone. Welcome to our webinar, Fluentd, the best kept secret to unify logging on AWS, Docker, Google Cloud Platform, and more. My name is John Hammock, and I'm a developer evangelist for Treasure Data. So this is our agenda for today. First, we're going to touch on the need for unified logging, what it means to get logs from many sources unified. We're going to dig into some of the existing problems that logging currently presents to us, specifically if you're in DevOps or if you're logging for analytics. I'm going to give you a brief overview of which of these problems Fluentd solves, and this is going to serve as a nice segue into how Fluentd solves them. Lastly, after looking at the architecture and some of the technical details, I'll give you a live demo showing you how Fluentd as a data collector can work with Docker. In our demo today, which is going to be up in a few minutes, we're going to show you how to run Fluentd in the host machine outside of the Docker container. We do this because as containers are ephemeral, our configurations would also disappear once the containers were destroyed. However, there are also reasons why you may want to run your Fluentd from within your container, namely when you're only interested in what's happening within a specific container. Now, Docker released version 1.11 on April 13th. A couple of months ago. Since Docker version 1.8, Fluentd has become shipped with Docker. Nonetheless, we have a guide available to help you set up Fluentd on Docker from a DigitalOcean droplet. So let's get started. Our first real problem that we're trying to solve with Fluentd is the notion that logging is really a mess. Many organizations, what you're seeing on this screen now is fairly typical for many data engineering teams. What we typically observe is a gaggle of information sources, all of them loosely coupled. And for every input, there are as many, if not more, data target systems to where the data is destined. So for example, a lot of information is being generated in the form of log files such as Apache HTTP server logs, syslog-ng, Twitter feeds, so forth, and all of these things need to go to a variety of destinations. For example, maybe Hadoop or maybe Elasticsearch. In one instance here, we're using data from syslog-ng or syslog, and it's being routed to Amazon S3 for archive. It's being routed to Elasticsearch for real-time search and so forth. Let's not forget about data from our mobile apps, from our social networks. The result is a cornucopia of point-to-point scripts, each serving a distinct function, but none or very few having any relationship to each other. You might, for example, have a script just to parse your Apache web server logs. You might have another script to aggregate data from a single data source, such as both of the mobile apps. Another script in this scenario might join data from our syslog and other parts of our system. Maybe there's a one-off Ruby script that gets data from Twitter and sends it to Hadoop. You get the idea. The more you build out your logging pipeline organically and make your integrations point-to-point like this, the more it's starting to look like one happy mess. Try imagine to maintaining this when the person who builds this infrastructure leaves. Another problem, of course, that comes out of this is that we're not logging enough. So where complexity is one of our problem, our other problem is one of velocity and throughput. So here we see the data volume plotted against time. As a greater and growing number of companies start to build mobile products and expand their web offerings, there correspondingly grows the number of devices connected to the internet or data sources. However, due to complexity of collecting these data to a single location, there is an ever-widening gap between the total data volume available and what actually gets collected. So what can we do to close this gap? Well, goodbye complexity, hello simplicity and flexibility. Fluentd works by way of an old software development pattern or by refactoring a software development anti-pattern depending on how you look at it. In essence, it goes from integrating point to point, where our level of complexity is m times n, to integrating around a common interface, to where our level of complexity is reduced to m plus n, and we now have is everything integrating around a common interface. So Fluentd replaces these dozens of loosely coupled and uncoupled script with a simple mechanism with input plugins and output plugins that can listen to all of our data sources and route the data into the correct places without introducing unnecessary complexity. So how does it do it? Well, Fluentd is an extensible and reliable data collection tool. When I say extensible, I mean that it has a core, which is augmented by various plugins. We'll go over these plugins in a little bit more depth later. When I say it's reliable, I mean that among other things, it has buffering, high ability failover, and load balancing built into the core. What you don't have to do is rely on an external message queue to ensure reliability and robustness. Finally, Fluentd is designed to collect data from a potentially infinite number of places. In that sense, you can argue its similarity to syslogd, except that Fluentd is far more configurable, flexible, and versatile. So one of the core differentiators for Fluentd is the way it's designed. It has a core, as well as a thriving ecosystem of third-party plugins. The core focuses on the common concerns of collecting and managing event data, while the plugins focus on specific use cases by augmenting the functionality of the core. In other words, the core focuses on dividing and conquering the ever-growing volume of data. Fluentd buffers and retries data transmissions in the case of an unstable network. The core also does all kinds of error handling, such as formatting data, parsing data, and sending data from one node to another. It also subsequently handles message routing. Last but not least, the core also handles parallelism. That is, as your data flow intensifies, you'll want to distribute your workflow across multiple processors. Multi-threading and multiprocessing is also built into the core. Now, on the flip side, the plugins handle user-specific concerns, so reading data from specific data sources, parsing from and to specific data formats, buffering data with configurable parameters, writing the data to where you really need to send it in the format that you need. So let's dig into the plugin architecture a bit. There are 6 types of plugins. Input and parser plugins take care of taking in data from various sources, such as syslogs, mobile apps, web apps, social networks, and various sorts of middleware, and of course parsing it. Once the data is in Fluentd, it goes through an optional filter plugin to modify the data or filter the data midstream. You might want to mask certain fields or redact them, and you might want to even send data to different places based on the value of certain fields. At this point, the data is output to different systems. So buffering is built in. If an output to a certain backend fails, it can retry based on that buffer data. Formatting is going to be your last step. Certain systems or stakeholders require that data be formatted in certain ways. Although all activities can be the domain of plugins or the core, generally speaking, all inputs can break down into input-ish and output-ish. All of this can be scripted, of course, inside of Fluentd itself. So let's dive a little more deeply into the lifetime of an event. As you can see on the left, a Fluentd event consists of 3 parts. We have a tag, a timestamp, and a body record. Now, your body record is essentially the payload or message that you want to move between systems. Your tag is a very unique ID within Fluentd. Essentially, it's a piece of text that tells Fluentd where to send the data. Given the tag a prefix such as S3, MongoDB, treasure data, and so forth, this will allow Fluentd to know where to route the data. And we're going to see how the tag is implemented in our configuration files in a moment here. You can also configure it with flags like production or development so that it routes data to the right servers for the right environment. Now, time is very important as all log data comes with a timestamp, as does all time series data. So knowing exactly what time an event was processed is key to knowing that the backend understands the meaning of the data and the context of the data. Once the data is input into Fluentd, it goes into the router mechanism. So based on the value of that tag, this is where routing happens. If the tag says foo, it might go to one system. Bar sends it elsewhere. So each event, once it's routed to different outputs, can be buffered in its own way. Once the buffering is done and you're flushing the buffer, the data goes into a queue. That's the output plugin's write logic. You might be writing to an external system over the internet. You might be writing to your own file system. You might be writing to a local database or a remote database. One key takeaway is that all this logic is abstracted away from the user. When you're using Fluentd, you don't have to worry about these mechanisms. Simply write a declarative configuration file, and that's going to show you how you manage the data flow. So let's go into a couple of use cases, and let's look at the configurations behind those use cases. So our first use case is probably the simplest, and it's probably also the most common. This is where you're basically collecting data from many different sources. We're routing it to Fluentd, then we're outputting it to an external system such as MongoDB, Postgres, and so on. So today, Fluentd supports more than 200 output systems, making it a very versatile choice with which to start structured logging in your organization. So this configuration would look like this. So we have our sources. Our sources is where we're getting the data from. My source tag says, okay, we're using the tail input plugin, so we're tailing our HTTPD log. We're doing that in format Apache 2, and we're tagging it backend Apache. So keep a note of that. We're also getting logs from client libraries, so we're forwarding from port 24224. Now, if you remember our tag backend Apache, you'll see that there's a match backend star, so a little regular expression there. That's taken, okay, the stuff that's routed to backend Apache is going to be sent matched to our backend star, and it's going to go to our MongoDB. So we're sending it to Mongo. So we have our output plugin is type Mongo. Our database is going to be called Fluent, and our MongoDB collection is called Test. And the one thing that I left out of this, and I'm sorry, but there would be another match for PostgreSQL in this case. So there may actually be two configurations under the match parameter. Here we have one. A less simple forwarding is what happens when, for example, your system starts to scale. So once you have simple data forwarding covered, you can go on to do more advanced data forwarding. So in this setup, you're using Fluentd to load balance among multiple Fluentd nodes. So in this view, we're collecting data from many different servers with many different data sources such as mobile apps, our local file system, our syslog, and so on. Now those leaf Fluentd instances are forwarding the data to the big aggregated instance that you see here in the middle. You can also channel overflow. So if one aggregated node is full, you can configure it to gracefully overflow into another one. You can also do load balancing so that you're sending data not to just one aggregated node, but to several. Once the aggregator gets all the data, it periodically sends data to all the back-end systems, which are shown on the diagram here. Again, the fact that Fluentd supports more than 200 output plugins make it very appealing. So it can adapt to your own environment without any coding. One of the more advanced use cases we're starting to see is Lambda infrastructure. So proposed by Nathan Mars back in 2011 or so. This is an infrastructure where there were two storage systems, one for real-time low latency data store, and another for historical data. Now, why would we want to do that? Say we have a system where we have we're doing the speed bump thing. So there's a system we have which basically monitors the traffic going over the Öresund bridge between Malmö, Sweden, and Copenhagen, Denmark. What that does is every time a car drives over the speed bump, it takes a snapshot of the car's license plate, converts it to text, and stores it in a database with a timestamp. Now, we might be interested in querying trends over the last hour, and we want to see what's happening in real time. So we can query, for example, for license plates with a certain prefix, and we can see, for example, where people tend to be coming from. Now, we can do that in the last hour. We can do it as the data is actually coming in, and this would be something for a very quick, low latency data store. Maybe this is good for the last hour, but what if we want to look for trends over the last year? Well, we would want something that's probably a little higher latency, but more of a historical data store. So in this example, we're sending our low latency data, the data we want to query quickly over the very short recent period of time. That's going to Elasticsearch for text search, and our longer historical data in this case is going to Hadoop. So Fluentd is an excellent choice for this kind of a configuration due to its ability to copy data streams and send data to divergent locations. Again, we have Elasticsearch here for real-time search and analytics, Hadoop for historical storage and analytics. Another use case, I gave you the speed bump example in Malmö. Another example could be, for example, for fraud detection. So say you run a historical machine learning job on Hadoop, and after creating an estimator, you feed those trained parameters back into Elasticsearch. You'd be able to flag fraudulent users in real time this way. Fluentd would be the log detection mechanism which could power this. So let's look at how a Lambda configuration like this might be configured in a more simple case. So again, we're sourcing our data from, we're tailing our HTTP logs as an example. We're tagging it as web access. We're also forwarding for port 24224. Now we're storing the logs to both Elasticsearch and Hadoop file system. How do we do that? Well, we're running a general match, and we're matching everything that has pretty pretty much any tag. So star.star is kind of our wild card irregular expression. Of course, we're matching the stuff from web access or from any other tag, really. We have two different stores here. Under the first store parameter, we're using our Elasticsearch output plugin, and we're setting our logstash format that is configurable within that specific output plugin to true. In our second store, we're saying, okay, I'm going to use my web HDFS plugin. So I do type web HDFS. I'm going to call my host name node. I'm going to specify port 50070, and I'm going to specify my path on Hadoop file system. So that's a very basic example of how I might do a Lambda architecture. I recently, actually just yesterday, did a short scenario logging to Google Cloud Platform. So Fluentd currently has an output plugin for, among many other things, Google Cloud Platform and Kubernetes. Logging to these platforms works quite similarly to other logging platforms. But what's interesting is that GCP Output Plugin has quite a few things of its own that you can take advantage of as well. So again, we're getting the sources from the same place. We're tagging it as web access in this case. We're doing basically a full wildcard match. That should be star.star there. Sorry, my mistake. In this case, we're using the Google Cloud Output Plugin. We have a few settings that are specific to this, so our detect subservice is set to false. However, some of these things would seem to be specific to Google Cloud Plugin or generally configurable within Fluentd as well. So we can set, in this case, our buffer chunk limit to 2 megabytes. That means when we're sending chunks, we can limit the size of those chunks to 2 megabytes. Our buffer queue limit we can set to 8. Our flush interval is 5 seconds. Sorry, the buffer queue limit means we don't want to have more than 8 queues in our buffer at a given time. Flush interval is 5 seconds. That means that every 5 seconds, we're going to flush our data and send it to wherever the destination is specified. In this case, it's Google Cloud. We can wait a max retry every 30 seconds. And we can actually disable the retry limit as well. And I'm going to say that, for example, the flush interval, buffer queue limit, buffer chunk limit aren't necessarily specific to Google Cloud Platform. They're also configurable within Fluentd itself for other output plugins as well. So I'm actually writing a blog right now where I'm going to go into more specific examples of things you can do. For example, parsing logs with regular expressions and sending those to Google Cloud Platform as well. So that's going to be a lot of fun. Of course, our other case, one that we're going to look at today, is container logging. So as Docker and container-based architecture becomes more prevalent, we need to find a way to log it, right? So because Docker containers are ephemeral, as I mentioned before, it's important to archive the log data outside of the containers on the host. Because of course, when those containers disappear, so does all of our configuration as well. Again, the exception to that is if I'm only interested in logging data from a specific container, and I want to isolate that data. In that case, I might configure Fluentd instance within the Docker container. Okay, this is of course why in our demo that I'm going to show you, Fluentd is running in the container, but we're going to configure it explicitly on the outside of the container, on the Linux host and in our file system. So luckily, Fluentd is one of the logging drivers supported by the Docker core. So if you're running Fluentd on your host machine, you can instruct your Docker container to send all of its logs to the Fluentd instance running on the host machine itself. Again, once the data is funneled into Fluentd, it can take advantage of more than 200 open source community supported output plugins. Fluentd itself, by the way, is open source, so everything I'm pitching to you here is absolutely free and open source. This makes it easy for you to do your Docker-based architecture and to have a sound logging system from day one with open source tools that are free. Fluentd's user base is growing all the time, so OpenShift, Red Hat's platform as a service, uses Fluentd as well. There's another example that's come in. We're having examples of this coming in all the time, so Fluentd is starting to be widely picked up and starting to be kind of widely used as a default logging architecture in a lot of scenarios. So we're going to jump into our demo. And what I'm going to do in the demo is I'm going to log into a Docker container. I'm going to show you how I have Fluentd configured. We're going to restart Treasure Agent. We're going to spin up and launch an actual Docker container, and we're going to basically do a very simple scenario where we log standard output from the console in our Docker container to Treasure data using Fluentd. So let's get started with that. And I'm going to clear this out. And I'm going to SSH into my machine. So jamming to Docker demo. I have my Docker instances set up on DigitalOcean. It's very easy to set up Docker on DigitalOcean as well. So what I plan to do, if I get enough interest, is to actually produce a guide showing people how to set up Fluentd on a Docker container on DigitalOcean. It's dead easy, right? So great, so we're logged in. We're now into the host on which we will run our Docker container. But the first thing I want to do is I want to show you what TD Agent configuration looks like. TD Agent, by the way, is Treasure Data's supported version of Fluentd. In case you didn't know, Treasure Data are the folks who developed Fluentd. And maintain it as an open source tool. Our TD Agent is our fully enterprise supported version of Fluentd. But for our purposes right now, these are basically one and the same. So if we're looking at TD Agent Conf, we're also looking at Fluentd Conf. It's basically one and the same. So let's just do this. A lot of you folks out there are going to hate me for using Nano. I just find it great, easy to use. Text editor. I know probably many of you prefer Vim. Of course, you can use any text editor you want. So let's log into TD Agent Conf. And here we have, we're basically doing forward. So our source parameter says we're just going to forward. That's it. That's all we're going to do. And I'm going to match everything that's tagged TD. Essentially, I'm going to match basically everything. I'm going to use a Treasure Data Log Output Plugin. I've got my Treasure Data API key here. And I've got a few things that are specific to Treasure Data that I can do here. So on Treasure Data basically is a cloud data analytics pipeline. I'm going to auto create a table. I'm going to buffer my data to a file on Treasure Data, and I'm going to specify a buffer path, and I'm going to flush my buffer every 5 seconds. So that means that every 5 seconds, the data is going to go from my buffer into a table on Treasure Data. I'm going to show you what that looks like in a moment. And we're also going to match everything for our standard out. So everything that's tagged Docker. When we dump to console, we're going to basically use our standard out plugin to pull that in. Now I have also a secondary configuration here for failed records as well. This would kind of be a backup system if other things weren't working. But I'm going to show you how this works. So we're gonna log into a Docker container. We're going to type some very simple echo commands from within our Docker container. And we're going to echo those to console, and we're basically going to send that data to Treasure Data by way of a very simple example, which I hope illustrates this. So the next thing we're going to do is we're going to restart Fluentd. So in this case, we're calling it TD Agent. So we're going to do basically a typical service restart. Which looks like this. We're just going to hit enter. It's going to restart it for us. So we now know that it's running. If we did a PS command or whatever, we would be able to see what's going on specifically. So now what we're going to do is we're going to launch a Docker container. In this case, Fluentd has also been launched, and our database and table that we're going to be writing our data from this container to is going to be the name of the container. So how do we do that? So I'm going to use sudo to do this. Docker run -ti, right? We're going to name our container test. We are going to specify our log driver as Fluentd. We are going to specify our logging option as Fluentd tag, and this is going to equal td treasure data, td docker. And so the name of our container is going to be the name of our table on treasure data. And I'm going to show you how that works. So we do this, and then we do Ubuntu bin bash because that's what we want to start. Sorry, sticky fingers today. So let's fire that up, and we're now inside of our Docker container, right? So now everything that's going into standard out should be routed via Fluentd into treasure data. And I'm going to show you what that looks like. So let's do a very simple thing. We're going to do just simple echo 1. Echoes 1. We're going to do a simple echo 1, comma 2. And it echoes 1 and 2. Now notice that there is me typing the command and there is it actually echoing it as well. Each of these things is going to be a separate row in my treasure data table, which we'll see in a moment. So let's do echo 1, 2, 3, and of course you can echo anything you want here, and it would show. So echo how much wood could a woodchuck if you get the point, right? So right, so for each thing we have the echo command that we're typing, and we're having the actual echoing of the command. Pardon me. So now that's done, we should have flushed our interval already. So let's just we're going to go to treasure data console and see how the data was actually imported. And let me refresh this. And I now should see that there is a new database created called Docker. And I name my container test, so there's a new table name called test. So what actually happens if we query this? So we're going to go to treasure data console. We have a possibility to do queries here. We can do a Hive query. We can do Presto queries. Hive is, of course, Hive and Presto and Pig are actually ways of kind of doing an SQL query on Hadoop. In the case of Hive, this is good for batch level queries. Presto is much better for doing exploratory queries that generally don't require more than one MapReduce cycle. And it's also worth mentioning that Presto can actually draw data not only from Hadoop, but it can draw data from multiple sources. For example, if you have some data on Hadoop and you have some stored on S3 buckets, you could be able to write a Presto query that queries data from both as if it's pulling from one source. So that's a pretty nice feature of Presto. Presto is, of course, widely used at Facebook. Facebook is one of the main contributors to the Presto query engine. As are we. So let's write a Presto query against our table called test in our database called Docker. Very simple. Let's just select everything from test and let's run it. And we should have had time to get all of our data. So we're having 10 records now, right? We see that we have our echo 1 and we have actual standard out, which is 1. So remember, we had the echo command and we had the standard out as well. We had our echo 1, 2 with 1, 2. Looks like I have my exit command from a previous session here. Sorry about that. We have our echo 1, 2, 3 as well as the 1, 2, 3. And our how much wood could a woodchuck chuck both as an echo command and as actually echoed. So we should see our 8 records, but we have 10 because I have my exit command from a previous session. Sorry about that. But as you see, everything's being routed from our Docker container via Fluentd to, in this case, treasure data. Of course, we can use a Fluentd Output Plugin to route it to any of those sources that we talked about earlier, as well as any of the other output plugins. And why don't we actually jump over and look at some of these others? So if you go to fluentd.org, we can see actual what's going on. Of course, it routes to the Fluentd Enterprise page. Ah, right, I know what I did. I hit the Fluentd Enterprise Edition and it took me to Treasure Data. But if you go to fluentd.org, you're going to see everything you want to see about Fluentd, including an explanation of what it is, how it works, certainly who is using it. If you click through each of these links, you're going to be able to see some different use cases for how all these different companies are using Fluentd as their own logging framework. I want to show you a couple of other things. So we talk about plugins. So Fluentd has an ecosystem of input and output plugins, which are like Fluentd itself, open source. Now we can look at our plugins by category. So if we just do /plugins, we have our list of plugins by category. These are our Amazon plugins. We have it's kind of a mixed bag here. So we have output and input plugins mixed together. Now, installing these plugins is simple as installing any kind of a Ruby gem. In fact, Fluentd itself is installable as a Ruby gem as well. So if you're familiar with how Ruby is installed and managed and how Ruby installations work, then this should be pretty easy. You can install Fluentd, and then the input and or output plugin that you want, you configure it as we have seen earlier in the configuration file. We've got Amazon, Kinesis, Firehose. I mean, pretty much everything Amazon you can think of. Redshift is obviously a very popular one. So-called big data, so HBase, Web HDFS, and of course Treasure Data. We have a separate section for filter plugins, right? So ways we can change our inputs. So we want to anonymize records, we can do that. If we want to add messages to our plugins, we can do that. Different ways we can manipulate the data once it's in. Timestamp checking and timestamp configuration is a big piece of this, of course. Geo IP filters as well. A lot of things you can do. Check out /plugins. Now you're probably looking at all these. We got Google Cloud Platform, like we talked about. Unit IoT. We're starting to see a few showing up there. Of course, monitoring plugins, notifications, NoSQL, all kinds of stuff for RDBMS, input and output plugins. So you can route data from, for example, your MySQL. You can route it to Postgres or MySQL. And this isn't even an exhaustive list as well. There's probably a lot more that's even showing here. Search things like AWS Elasticsearch itself, and a whole bunch of other stuff too. I don't even believe this is exhaustive. Of course, it's open source, so new things are being created all the time. Now, you're probably wondering, well, I'm looking at all these plugins and I'm thinking, which of these things are reliable? Because it is open source. How do you know? Well, two ways. We have certification. And we're going to talk about what the certified plugin means in a moment. But also, if you go to /plugins/all, you're going to see that these plugins are sorted in descending order by number of downloads. Now, this suggests that these are by far the most popular ones at the top. And of course, the certification, which we're going to cover in a moment, means that these are generally fit for purpose. In fact, why don't we look at that now? What does a plugin certification mean? So if we jump over to frequently asked questions, it actually asks that question. What does certified mean? Well, plugins marked as certified are developed by either our core committers or by companies who made the commercial commitment to Fluentd. Since we made it easy to develop the plugins, we have 500 plus more plugins, and we started hearing from people saying that it's hard to figure out which plugins are easy to use. Of course, not certified plugins are also used by a wide variety of people, but this will at least help you navigate through some of the core ones. So it's not an exact system. We might as well talk how Fluentd is developed. Fluentd is written in Ruby. So how about the performance there? This is one of our very frequently asked questions. Most performance-sensitive parts of Fluentd are actually written in C. So our Ruby code is acting as a wrapper, acting as basically an API wrapper that provides some flexibility to the overall solution, um, while keeping the more performance-sensitive parts, of course, in C. Um, Particularly the networking layer and our object serialization are written in C. And you can read more about it by looking at Cool.io and MessagePack, both of which are from Fluentd maintainers as well and are complementary solutions. However, since it's not written entirely in C or C++, it may be slow in its Ruby parts. However, by sacrificing a little bit of speed, we have gained many plugins from the Ruby community. So actually, by opening a lot of it to Ruby, we're getting a lot more contributions, which is something we need. We need to cover more surface area with these plugins. Obviously, a lot more people are fluent in Ruby than are fluent in C, so this helps a lot. Of course, if we find a certain execution path through this as being more widely used, we might go back and re-implement it in C. So this is, of course, continually changing. I hope this all made sense to you. If you'd like to get an easy logging infrastructure, well, I showed you Fluentdorg. Oh yes, and the other thing I want to show you is treasuredata.com. So if we go to treasuredata.com, you have a possibility to sign up for our 14-day trial, and you can try out Treasure Data for yourself for free for 14 days just to see how everything is working and looking there. I showed you the plugins. I showed you how to sort them by category and how to sort them by how widely they're used. So now that you know about Treasure Data, you know about Fluentd. Obviously, if you're interested in it, you can check out Fluentd or you can check out treasuredata.com. Treasure Data is the creator and primary maintainer of Fluentd. So if you have any questions or suggestions for us, don't hesitate to reach out.